Good morning, everyone. In this video, we're going to cover the topic of the visualization of complex networks. So in this sense, this is not a tutorial about basic network analysis where you learn how to change the color of the nodes, how to have different type of layouts. For this type of tutorial, you can find very comprehensive resources online. So this one, for instance, this link here will give you read the basics of network visualization. But what I cover in this video is basically the visualization of complex networks. So very large networks that have a very high number of nodes and a very high number of links. And these complex networks are very tricky to visualize because if you just plot them without any transformation, you basically see nothing because everything is connected to everything. So that's something which is absolutely useless. So we have to find a way to trim these complex networks to basically extract the overall structure, the backbone, and see an interesting pattern. So what we're going to learn in this video is to compute a maximum spanning tree. And a maximum spanning tree will basically reveal the backbone of a very complex network. And there are three rules to do that. The first rule is we only want to keep n-1 links. So if we have 100 nodes, we're only going to keep 99 links between these nodes, n-1. That's the first rule. Now, you don't do that randomly. You just don't keep random 99 nodes because otherwise you would not have, the real backbone of the network. So rule number two, we're going to remove the links with the lowest weight. So if we have to choose between a link of a value of 100 and a link with a value of 10, well, then we remove the 10. But it's a little bit more complicated than that, because if you only remove, the real lowest link, the link with the lowest value, then basically you're going to create isolates. So a very small node that only has one link to another node, and this link is very, very low value, will basically get cut if you apply this rule strictly without any other additional rule. And so we're going to have a third rule, which is we don't want to create isolates. So even if a node has only one link and very low value, then we're going to keep this, because if we will cut it, then this node will be isolated. So if we follow these three rules, we basically will reveal the backbone of the network, and we'll be able to visualize very complex networks. So let's start by creating a relatively large network. So in this case, let's create network M, and we give some kind of value. So you have like 93, 9, and it's a 200 by 200 matrix here that we have. Okay, so you see it's a valued network. Then if we use igraph, we can plot this network. But what we're gonna see here is like, well, sure, we can plot it, but we don't see anything. So it's absolutely useless in this case to represent a network like this. You have no idea of what's going on. So a network like this can be trimmed, and that's what we're going to do together. You see there will be very, very few lines of code. The first thing we want to do is to multiply this graph by -1. Okay, so if we look now at M, multiply by -1, we have something different. We have like the same numbers, but negative in this sense. And the reason why we do that is because we're going to use a function in igraph which is called the minimum spanning tree. So it's just doing exactly the inverse, the other way around, as opposed to what I was telling you. So I was telling you that we want to keep the links with the highest value, but the only function we have in igraph is a minimum spanning tree that does the opposite. So what we do is like we're going to apply a minimum spanning tree on a network with negative values, which basically going to give us a maximum spanning tree. Simple as that. So these three rules here will be incorporated in the minimum spanning tree algorithm in igraph. So first thing we do, now that we have our our new graph, new data frame, we're gonna create a new object G where the value in this case are negative. And on this graph G with negative value, we're going to apply our minimum spanning tree, which is going to give at the end the equivalent of applying a maximum spanning tree on positive values. Simple as that. So we create an object called MST using the function minimum spanning tree on the graph G. And now if we plot this graph, then you see that we get something much nicer where we actually can see something. So we have, of course, it's still a very large network, you need to trim it, but then we get a more clear understanding of the key connection in this network that basically form the overall underlying backbone of the network. And that's what we do to create the product space, the technology space, and we can go from like really large complex networks where it's very difficult to see the essential connection, and using this technique in this couple of steps we basically can visualize these complex networks, and then to extract the different edges, then you can just do this using the get adjacency MST, and then you get this MST in this case.